So example 2 is let f of x equal 1.2 to the power of x and g of x equal 0.92 to the power of x plus 5. And it asks during what interval is f of x greater than g of x and g of x greater than f of x. So we have to apply the same technique in this example too. We have to graph both of the functions and then just see where f of x is greater than g of x and g of x is greater than f of x. So for f of x, since it's an exponential function, we know the key values will be -2, -1, 0, 1, and 2. And since the base is 1.2, y values will be 1.2 to the power of x. So 1.2 to the power of -2 is 0.694. And the dash on top basically means that the 4 continues on. 1.2 to the power of -1 is 0.83. 1.2 to the power of 0 is 1. 1.2 to the power of 1 is 1.2. And 1.2 to the power of 2 is 1.44. So we have to do the same for g of x. And since the base is 0.92 and it's getting shifted up 5 units, that means the horizontal asymptote is going to move up 5 units on the graph. So the y values will be 0.92 to the power of -2 plus 5 is 6.18. 0.92 to the power of -1 plus 5 is 6.08. 0.92 to the power of 0 plus 5 is 6. 0.92 to the power of 1 plus 5 is 5.92. And 0.92 to the power of 2 plus 5 is 5.84. So now that we have our values for both of the functions, we can basically plot them on a graph and then see when f of x is greater than g of x and g of x is greater than f of x. And I've already done that before to save time. So since it can be seen that f of x and g of x intersect at approximately 9.2 or 9.3, I would say 9.3, and when the value of x is greater than 9.3, g of x approaches 5, so it's basically its asymptote, but f of x continues on forever. So that's one of the so for basically part I, for part A, when f of x is greater than g of x, the interval or the x value would be that when x is greater than 9.31,